Very good evening to everyone. So we have a very broad topic today, that is Industry 4.0 and the future of manufacturing. Can everyone hear me? So Industry 4.0, it's the biggest structural change that has happened in the past 250 years. A transformation of scale, scope and complexity unlike anything the humankind has experienced before. Now the organizations understand the benefits and the promise that Industry 4.0 offers. It's faster, smarter and sustainable productivity. But what is hard is making this promise come true. Then Industry 4.0 is about creating the next generation of operational excellence with smart automation, connectivity and operational alignment. What will come out of all this are connected ecosystems. We are seeing that already, and the companies that take advantage of them will gain a competitive edge. The father of Industry 4.0, Henrik Van Tree, describes three key drivers for the success. Think value, not tech. Think people, not tools. And set clear targets right from the start. The impact of Industry 4.0 in the Indian manufacturing context has been transformative and really revolutionizing manufacturing and the technology industry sectors. However, challenges like skill gaps, infrastructure limitations, and cybersecurity concerns still persist. So, what we need are strategic solutions for sustainable adoption and maximize benefits. So, in this panel today, we will be discussing and we will aim to explore the implications, challenges, and boundless opportunities that Industry 4.0 presents to the manufacturing sector, and we will attempt to decipher the roadmap for harnessing Industry 4.0 to craft a more efficient, agile, and sustainable future of manufacturing. So, to start with Dr. Naga, from your vantage point at the Central Manufacturing Technology Institute, can you shed light on the role of emerging technologies like AI, IoT, and automation in shaping India's manufacturing landscape?
Good evening. You may be knowing about CMTA. CMTA is a only national lab focused on manufacturing technology that to machine tools. Last 61 years, we built more than 500 machines designed, developed in the country first time. While doing this, naturally we expanded our activity to cover some of the aspects related to process technology, then the automation system, and now on the smart manufacturing, sensor development law. What I perceive in Industry 4 is not a technology, it is kind of a mindset. If you look at Indian companies, mostly the MSME companies, even today, shop floor is managed by the so-called expert, somebody, some Sharma, somebody you can take. If anything goes wrong on the machine, the operator is first correct to him, and by sitting in his office at his chamber, is doing something like this. So that is one context. But if you look at the Western developed countries, the manufacturing is entirely different kind of paradigm shift. You can easily look into this. So now the contest is, does it Industry 4 is the right elephant for an Indian company, or is there an opportunity for us to encash that benefits? Industry 4 essentially, what I understood, I'm sure everybody knows by this time, has four fundamental components. One is that the overall purpose is to understand what you do. That is the reason Industry 4 is implemented even in cake manufacturing. Once you understand the process, you collect the data from the real source and digitize and share to the respective stakeholder. Stakeholders may be the owner of the company, or the maintenance in charge, or maybe the immediate supervisor. And then once you go to stakeholders will do some analytics, whatever the analytics, simple regression analysis to big data analysis, AML driven solutions. So that finally predicts something. So these predictions are always should be objective oriented. Everything cannot be done at one data, otherwise data is wasted, right? Then So what are the prediction findings you have when you put it back to the source where the data was generated to automate or to facilitate autonomous decision? So all these were happening because of one so-called expert. That dependency is gradually reducing. But if you look at the industry for implementation, that's you may be aware, our ministry, Minister of Heavy Industry, has supported to create a 4 center, one at CMTI, one at IISc, another at Pune, and then at IIT Delhi. The advantage, this was the first initiative came up from the ministry, and the idea was to develop the technology and then make industry's awareness to do research, convey what is the benefits and what to be done, what not to be done. What is our learning we are doing this is, yes, we established a smart factory, so one can always come and visit, have a look at, so you feel it was smart factory. But end of the day, whatever you do is ROI. Even today, the industry for the Indian context, MSME context, ROI is not assured. There are limitations to this. Globally, Industry 4 is quite successfully implemented for process industry, but for distinct manufacturing, still leaves a lot. So, for example, I will tell you. So, I am a job shop, I operate lathe. So, all mechanical engineer would appreciate if just you want to have achieve the known surface finish of RA of some value. Operate has only one of parameters to its success. But if you look at a mechanical engineer, at least mechanical engineer having 5 years experience, he can list at least 10 parameters that attributes to surface finish. So the challenge is that now currently whatever the solutions available in the commercial market are only limited to connectivity, then cloud computing, all those things. But process knowledge, process modeling is missing. So that is why ROI is still not visible. I think that is where we, being a manufacturing domain expert, CMP is working hard to develop such solutions to integrate with the IIT so that the net benefit of connected manufacturing could be realized.
Thank you. So, Mr. Prasad, how is the integration of IoT and digital engineering transforming the engineering manufacturing sector, both in India as well as in the global context?
Yeah, good afternoon. Thank you for this opportunity for Pivot to actually give us this talking platform. I guess predominantly, if you look at the industry today, I would like to break that into process industry and having different challenges. If you look predominantly on the discrete side and you look at the kind of products that are being made today, a lot has moved out of, I would not say completely mechanical engineering, it has gone out of software driven. Electronics is also very heavily embedded into these products. So if I wrote that like 20 years ago, we used to do a lot of CAD, CAD, analysis and things like that. The overall digital side of the engineering, now when you look at it, it's more software driven. I think Sanjay's speech earlier was talking about how we make the software defined networks. How do you actually move the hardware dependency more into the software side? So what people used to manufacture earlier is not going to be the same, or it's not the same at this point in time. So if you take any of the manufacturing sector, especially I'll take auto example. So like Tesla is actually a software kind of driven company. The way they're structured, the way they're organized is software driven. Whereas when you go to a very traditional GM in Fords of this world, they're very mechanical oriented. So even right from the organization structure point of view to redefine IoT and digital engineering being the core, actually has to change from those perspectives. So a lot of the discrete companies and discrete manufacturing is actually looking at it from there. And so everything will become digital, everything will be with IoT. And you get to the process side, again, we have very similar challenges, and slightly different again. If I'm looking for a brownfield opportunity, moving more or getting all the data in the process industry, doing the optimizations on existing equipment also becomes an existing is a very existential problem. The only way they can actually do better is to optimize what they're currently doing, like using IoT and digital engineering. But if you get to a green field, I think the biggest problem most of them face, even sometimes even in the discrete, is how to get a golden badge. So getting a golden badge, making sure that the golden badge is repeatable, and so you have to have, and so that is where problems start creeping up, because you think that everything can be done. Predominantly, we miss the core engineering and core engineering science. Everything comes with more Python and that data scientists. So you need to mix all the data science and the digital engineering, the core engineering, and not leaving out core of mechanical electronics and chemistry, physics. Bringing that together becomes extremely important for you to actually jump. So IoT and digital engineering predominantly becomes a fundamental piece. From the Indian context, if you take, for example, some of the established industries where we see, and I think Dr. Naga talked about it, we have legacy tools. So if you go to a shop floor, you can actually see legacy machine tools working in conjunction with latest state-of-the-art CNCs and robots. So how do you actually create a smart manufacturing setup that links something from a legacy on, integrated into the CNC programming with data science and IoT becomes another challenge. So these are some of the kind of typical challenges that we face in India. That all this becomes like an enabler for us to see how we can actually work out. Everybody talks about the leapfrog. So how do we leapfrog on this kind of constraints would be a big challenge.
That's very true. Coming to Dr. Nair, how do you perceive the impact of data analytics and AI on optimizing manufacturing processes? Could you share some examples of where these technologies have driven efficiency and innovation within the industry?
So, good afternoon, everyone. And, appreciate the opportunity Pivot has given us. Analytics and optimizing, we come more from the process manufacturing side. Ingenero as a company has been, ever since we started it in 2001, we have been doing analytics, deep analytics, advanced analytics for companies in the process industry, refineries, petrochemical plants, chemical plants. So there's semi-batch and continuous. And our whole business was based on taking data, sitting remotely and actually doing the deep analysis. And this was something people in the process industry do a lot of analysis and so on, but the depth of analysis on an operating plant was never really done to that level, which we were doing for the last, and we have continued to do that. Type of benefits that came from that were tremendous. I mean, increases in production, 5 to 10% depending on the type of facility and where they were. Being able to identify pinhole leaks sitting halfway across the world, being able to detect something like that, tremendously improving the reliability, safety, reducing emissions, increasing energy usage. Now, what Industry 4.0 has done, it's taken it to another level. So this was done on a shift-by-shift basis. So with the current AI systems and so on, which we started really implementing as end-to-end real-time solutions. We've been doing that now for the last 8 to 10 years. It was a natural, but it had a lot of other things that had to be integrated, co-enabling technologies and so on. And then there was another step jump in type of benefits, very similar areas. And that's kind of what we've seen so far, the benefits of optimizing and analytics on manufacturing.
Dr. Naga, in your experience, what are the key challenges and opportunities that we as Indian manufacturers have when we adopt in Industry 4.0, and how can an institute like yours help them and support, more than help, support the industry in overcoming these challenges?
I think the key challenge which I understood from last 5-6 years working with the customers of MSME as well as a big company, one is the mindset. I think first thing that there's also like now if you look at Industry 4.0, either people will last with these buzzwords, or a lot of things happened in parallel and nothing is mature. As such, there is no universal solution. Industry 4 to be done, it can be implemented to a machine, to a shop floor, to a factory, or a complete operation with the distributed manufacturing. So what we need to do, I will give you a specific example. We have developed some solutions. The solutions are implemented to a MSME which has only 4 machines and is operating by father and son. And we also implemented similar solutions to a big company, OEM, right? Which has about like in one shop floor, we implemented for maintenance, which has about 64 machines. Each machine we capture about 17 parameters, and we then do the analytics and complete solutions we have developed. The question is, if you look about the MSME, the major challenge is how to acquire the data. Earlier, if you look at maybe when we were kids or when we started our career, the data was recorded by operators logbook. They used to record what was the process conditions when we start operation or what was the. I think now the digitization happened, but still MSME, we don't have that skill set. So that is the first point. The second point, if you go to many MSME, so still even not to the industry too. They don't have a computer. They take shop floor, they don't have a computer. And that way works on some Excel and some accounting. I think that is another challenge where we need to address when we look at MSME. And third one, the MSME faces the retaining the intellectual manpower. The reason is after 6 months, if someone has used to like that, we face the problem. After 6 months, he works on some solutions, so observed by somebody else. This is always challenge for MSME. So naturally, lot of trust has to go on skilling and reskilling. That is one. And second one is particularly the guys who are focusing on MSME, because that is what our experience. When you look at the MSME who does the shop, why you will implement Industry 4? Definitely, still Indian manpower is not that expensive. Only you will be looking for a kind of solution. This is one example. Say, for example, if I go with a lot of solutions and say I want to do Industry 4, you will not bother what Industry 4, 5G, 4G, whatever you call. But what is interested is, say, for example, if my actual cutting time of milling machine is 35%, do you have a solution which could enhance to 45%, if not 60%? So then, I think that is the kind of solution basically MSME looks for. With respect to this, so still not much solutions are available. The reason is, as I said, my earlier example, the similarly was still process modeling. I think Sujatha was clearly saying, we are not focused on developing a knowledge base which is originated to my company, from my company, or to my country, or from my company. I think we need to focus a lot on that. Industry 4 would be implemented in the different levels. So I think one major challenge is the mindset. If we decided to do it implementation, you just have a solution. Your legacy machine could be made a smart machine just by investment of 4,000 rupees. There is an opportunity. One has to look into that. And second is, as I said, can you solve my 10 problems of 4,000 rupees investment? No, answer is no. So I think we need to figure out where we should and what we wanted, and definitely there are solutions.
So, follow up on that, what you said, has your institute or the government, are there any feasible strategies or frameworks that are helping SMEs and MSMEs in this transformation?
True. So, what I mentioned in the previous, that is the summer center. In fact, the summer center was started with that. The idea is developing a technology, this technology, creating an IP is a major focus for us. But at the same time, all the summer centers, including the CMTI, we have created a facility. So I will stick to my discussion on our. We have 8 laboratories we have created. These are all hands-on laboratories. So these are meant for training. So if anybody wanted to migrate to your company or your shop floor into a smart, CMTI today can help in multiple ways. One is that, okay, without changing your legacy machines, we can convert your factory into smart, which we already did for MSME and also the big company. The second is you want to train a manpower. I have 8 different aspects of Industry 4 technology, hands-on experience. We will conduct you training program as you require customized training program. The third one is, okay, I have this problem. As I said, for example, milling machine, I said just now. So we are looking for that is an objective, set objective. So we are being a scientist, so we study your problems, develop the process knowledge, and we will demonstrate and implement the customized solutions. The third one is there are some startups you are providing, you are developing some solutions, but you are not getting a test bed to prove it. So then you can use our test bed, CMT test bed. So these are the 4 avenues with the CMT.
Okay, thank you. Coming to Mr. Sai, when we were talking, we spoke about the upskilling and reskilling of the manufacturing workforce. So, what are the specific training programs or what are the methodologies that we need to upskill and train the current manufacturing force to adapt to the Industry 4.0, not just Industry 4.0, but the upcoming technologies like 5.0 and rest of them?
Yeah, thanks. So I will try to take this question in 2 halves. One is what we need to do for the workforce or for our customers. How do we educate them? And so there, there's a whole lot of change management that comes into picture. Predominantly, when you get into any of these IoT and digital engineering, you need to garner about 3 to 4 very strong departments in the company. One is the IT, of course, the shop floor and the manufacturing head, and then the enterprise business group. All 3 have to kind of come together. It becomes a big challenge sometimes to get all of them to have the same vision in terms of what they need, because everybody comes with their own set of constraints in terms of how do we implement some of these things. And in addition to that, you go also not just lower into the operators, who are actually using those machines. But they also need to undergo this change management to figure out how things need to work. And then again, I would like to break them to half. One is a very senior, experienced person. He doesn't believe in many of these things. He says, how can you actually automate or autonomously run some of these machines? Some of these machines are extremely critical and not allow you to have data science and AI and things like that to touch it. And the second one is all the younger workforce who likes, who is all used to the gadgets and stuff like that. When they see these legacy machines, they can't get put off. And let me give you one example of what I actually faced. This was about 6, 7, 8 years ago in Japan, when I actually went to digitally transform one of the shop floor, and we bought all these big, monitors where they can completely monitor what is happening in the shop floor, which was not there earlier, but the MES with integration with ERP and the PLM systems, they could actually get the whole data through. And what we were trying to do was give them electronic work instructions. So how do you give electronic work instructions to the operator to actually start using? We say, let's use tablets. And immediately I got pushback saying that, my hands are greasy, I can't touch the tablet, it doesn't work. And then you said, no, look, you can actually use clouds, which has this, specific touch points that you can actually monitor them. And they said, no, I will use a human, I will between the foreman and the operator every morning they exchange drawings. And they said these electronic work instructions won't work for me. All this, whatever TCS is trying to push, it looks like they're trying to ITify things and remove human touch. So we had to create videos and educate them to say how you hand over. In fact, we created a thing where the tablet was handed over instead of a drawing. So we have to do some gimmicks, but actually educating them at every level becomes extremely important. When it comes to people like us who are actually SIs and trying to upskill our people, there again, like I said earlier, you get a lot of data scientists, but understanding core engineering mixed with data science is an extremely important skill. So sometimes we kind of train a traditional engineer into data science or a data science person in traditional engineering. We have actually a set of courses at IIT Madras where we educate them on an MTech program to reskill many of our associates, but it's a very, very small number. We get one batch now, the next batch will come out the first week of by end of next quarter. So all I'm trying to say is, upskilling them, getting this data science and, mixing them with core engineering becomes an extremely important piece. But there's a lot that we can actually do in terms of scaling this up and bringing the, skilling our people to understand, how these problems are solved.
Thank you. Coming to Dr. Nair, you are an expert in the applied AI solutions part. So, what are the typical challenges that you have faced when implementing applied AI solutions in process manufacturing?
Yeah, that's a good question. None of these applications are without challenges. And, we have, over the last 10 years, implemented what today is called applied AI, end-to-end, taking data and then going for a real-time solution with deep analytics, using machine learning as well as hybridized traditional knowledge. So some of the challenges we've seen, actually, several of the customers we work with, they actually came to us after 2 or 3 failures. So just like Dr. Naga was saying, the discrete manufacturing, there have been same thing is true in the process. There have been a lot of failures, and why? It's never really the technology that's the interesting part. It's you almost always have to determine what your objective is. What are you trying to solve? There's no point ripping apart something that has already been solved if you're not going to be able to get more value out of it. So a lot of times there's this what I call the allure of dazzling technology. There are announcements that come and say, hey, we need that. Or you have a data science group that's freshly minted, wants to implement all the latest and greatest algorithms. But that may not be appropriate for the end use that you're trying to achieve. So this kind of slows down the pace of actually implementing things, and it becomes very iterative. The third part is, all this data is the fuel to all this. And so a lot of the times that is undermined. There is a misconception that you throw all this, what they call big data, into a black box and voila, you get, a great looking solution. No, it doesn't work that way. There's like Sai was saying, there's a strong need for domain expertise even at the data engineering stage. Being able to curate that to some extent. And then, yes, there's a lot of automated things for handling data and so on. So that's the third challenge. Oftentimes not really recognized, and then there are pitfalls to that. The other thing to recognize that in manufacturing, unlike in internet software where you can have 1 or 2 models and they'll serve billions of use cases, in manufacturing, each model has to be kind of customized. So the customization part is very important. You can build up, automate up to a certain level in these solutions, but there's a certain level of customization, which is very important. Where again, domain and the data science experience, the fusion of that becomes very important. And the last part that we found is all of these things work best in manufacturing when it's done on purpose. So if you have an on-purpose implementation, you know what we're trying to achieve, and then you work towards it and take it all the way. And there's a lot of hand-holding that has to happen. Like Sai was also mentioning, trust has to be built in the system, and that doesn't happen overnight. So there's a lot of pre-training, laying the groundwork on the people side of things, which oftentimes doesn't happen. And the technology solution is built and crossed over, very likely that it may not see the light of day. So these are kind of the typical challenges that we've seen, which has to be addressed for you to have a successful solution.
To follow up on that, one of the use case for applied AI will be the predictive maintenance strategies that where you can apply AI. So, how do you suggest that integration of applied AI in manufacturing processes enhance predictive maintenance strategies and optimize overall efficiency?
Yes, so these applied AI solutions, firstly, the core is going to be the model. Whether it's a data-driven model or data-driven model infused with some pre-knowledge. What it does, there's several applications to this. Predictive maintenance is one of it because what you're really now able to do is on the real time, you're able to track and monitor and automatically get flag anomalies that are happening in the system. So you identify deviations way ahead that otherwise you may have not caught. It is there very much, but human being by himself or herself will not be able to notice that a lot of times. And so that is where this helps with being able to do proactive maintenance. Of course, there are several other applications being able to improve efficiency. So just having the knowledge, the insights, the prescriptions or the predictions that are able to be generated from this, you're just able to operate a lot more efficiently. Not just maintenance, even your energy efficiencies, your the emissions profile, a lot of things you can juggle at the end of the day and come out much ahead.
Dr. Naga, coming to you. How is your institute fostering collaboration between academia, industry, and government to facilitate the integration of digital technologies into manufacturing process?
Yeah. So in the country, we are open to collaborate with any irrespective of size of operation or background. The reason is the machines which we build a machines which is of small tabletop, and we build a largest machine, have a footprint of like the biggest machine which CMT ever built was about having a footprint of 2.8 meters square. That is how basically we connect. We will never say no to any machine requirement. So let us know the process, we build a machine. And you want a smart machine, we build a smart machine. It's completely autonomous machines we build. And at the same time, yes, machines, as I said, as you require for the specific customer. Then, just while doing this, as I said in my first comment, we have developed 500 plus solutions. We never developed solutions that layer TR level. Many times we went to the particularly the IIT setup, IIT, where already something has been demonstrated. So we start from there, then we took up to TR level 8, 9. But similarly, many industry or academia, you have something you already demonstrated, you need to scale up. There are also government platforms, government opportunities. At least I will tell you one opportunity in our ministry. We have a capital goods scheme, particularly meant for machining. So where you can build the machines which are not available off the shelf within the country, with 25%, 20% contribution from the industry and 80% from the government. Now I'm seeing here we are having an industry accelerator. We are developing 16 machines. None is built at commercial in the country with 13 industry partners. Right. So there are several schemes there. Another scheme, even I'm chair of DST, Advanced Manufacturing Technology. I will tell you because it's maybe a little pain, but it is true. That is where I think we need to believe each other. Last call, we had a call of 4 categories. The first category was the basic research, which is primarily meant to academicians who could be able to demonstrate some concept. There was 389 proposals. 389 proposals. Then there was a second category where industry could collaborate, but need not necessarily to bring in money. But there should be a concept which is either demonstrated by academics or the industry, but they came together. The industry has the responsibility of taking that to IIT. We have 23 proposals. The fourth one, we have a COE. There was about again same total of proposals for them. But the third category was something is already demonstrated IIT, but industry has to come with 30% investment. That monetary investment. So believe me, there was not a single proposal. Single proposal. Then what it indicates? There are two. One is there is a set of industries who never care for technology development in the country. They have money, they go and acquire somewhere. There is another set of maybe is that whatever is done at the research labs or the academic levels have no meaning to business, which is good at my research lab, but it may not be good at the industry side. Or we never believe each other. Right? I think that is where the challenge lies. I think if you really want to bring, if you really wanted to be kind of leader in the manufacturing, we have to believe ourselves, as I fully kind of second what Sanjay was saying, we need to develop domestic IP. Unless we develop an IP, people will not look at us, we cannot remain as a service center. And at the same time, there is nothing we can't do it. Maybe I and you alone may not be able to do anything, but we together can do everything. That's what I think we need to focus. I'm sure we can able to do.
That was from the institute perspective. Coming to you, how can collaboration be a pivotal thing in driving innovation?
Yeah, thank you so much. So basically, what we are trying to do, at least in PCS, we have something called a co-innovation network. So if I look at the customer as the center, the customer's problem, we kind of put about 3 or 4 blocks. One is TCS research, of course. Then we have academia, then startups, and the industry partners. Industry partners, all the large ones, Google, Microsoft, AWS, SAP, and stuff. So we believe that solution is somewhere in the center. We may not know all the answers to it. Now, what we are trying to do in some of these cases is, especially academia, if I just talk about all the IITs and IISc, we are actually co-locating along with them in the research part. So at IIT Madras, we are all just last month we moved to IIT Kharagpur. We are centers in IIT Kanpur. IIT Delhi, we are actually doing something called the continuous biopharma manufacturing, which we have set up a small lab where we are trying to move things into a continuous biopharma. So all whatever comes from academia is predominantly put under the PRL 1 to 3 bucket. We don't take anything beyond that. But the next part is to actually industrialize what comes from the academia, which becomes a very hard part from a core engineering perspective on 4 to 6 TRLs. So there, most of the things we do it in-house, or sometimes we engage with startups and industry partners, not so much from the academia perspective. So that we leave the academia out and start moving it out. So anything that we get out of the lab, then the whole engineering needs to happen. And so that's the way we are moving things along. But yes, there's a lot of things that we can do jointly, and I don't think the problems that we are trying to solve today, not one person has all the answers, and that's a firm belief that we need the ecosystem, we need everybody to work together to actually get this thing going.
So, Mr. Nair, with the convergence with the physical and the digital system in manufacturing, how can companies ensure a balance between automation and retaining human-centric approach to operations rather? And what are the implications? What implication does this have on the working dynamics?
So if you look at these AI or applied AI-based solutions, you can broadly have two categories. One is where you try and automate rote tasks where the machine can do it faster, whether it's software computation based or robotics based. And there's another portion which is very important and significant today is it provides augmented intelligence to the human the workforce. So either way, and the one that provides the augmented intelligence is where you're able to take that, make better decisions, and also there are things that sometimes you don't know what you don't know, but it actually brings that to the front. So sometimes you say the best analysis is where you're able to ask better questions. So it drives you to do that. So in the former case where there's certainly the change that has to happen is there is a process. You can't just slap it on. There's a slimming and shifting, upskilling or reskilling, call it whatever, that has to be done. So you cannot just drop it in there and expect it to work, because there's always a lot of pushback to change. You take examples from the past when Xerox first came with their machine. At that time, everyone used to use these carbon copies. And actually, they did a poll before they introduced it to the market. And the conclusion was the Xerox machine will never work because we have carbon copies. So initially, the initial thought with the population is that, no, this is the way we've always done it. Likewise, the smartphones, more recent example, right? If you see, it took there's some who adopted it immediately, started using it. There's some who it took some time to get onto the smartphones. So there's always that transition, and that has to be. So the people aspect is very important when doing that. Some of these augmented intelligence pieces eventually they will also slowly evolve into getting automated. So the same slimming and shifting will have to happen. But if the whole people aspect is not taken care of, yes, I mean these things could be very tricky.
One final question, because without which I think we cannot move forward. We are talking about connected. This is what connected ecosystem. When it is connected ecosystem, we are also talking about security matters. So, how, sir? It remains a critical concern for for an increasingly connected manufacturing system. So, what are the measures that can be taken by the manufacturing sector to avoid this? Or contain?
It's a great question. Actually, I have an optimistic view on facing this because if you really look at what the shop floor has been, over the years, everything has been a closed door, nothing has been exposed on the internet. But predominantly now with IoT and digital engineering, most of the information which is within the shop floor is now exposed, right? But if I take every layer of IoT, be it right from sensing the OT systems to the networking layer to the cloud layer, or maybe doing the analytics on the edge, as well as the AI, all these layers are actually opening up new threat vectors for somebody to come and hack into the system. Right? So now what we're trying to do in most of these things is how much can we prevent the information that is not needed to go upwards into the network, or how do we prevent that anything coming down into the system. So at every layer, right from hardware security to software security systems that you have to employ, including on the networks, becomes extremely important. Let me give you one example of what we try to do. For example, one of the postal industries in Europe, it's not just security, also having privacy into this whole thing. So essentially, we're trying to figure out how much of the truck is utilized when they start loading parcels into the truck. We are using a regular security camera that is put to just monitor it from a security perspective. But incidentally, the camera that we are using from a partner is also redacting the face of the worker, because as per GDPR compliance, you really can't have a person and identify the person being put into the system, into their networks and software. So we have actually removed that so that network doesn't even get anything out of the camera itself. So there are places where you can prevent. And there are frameworks like that we use in, like for example, Microsoft Stride. If you look at that Stride framework for security, or the Linda framework from privacy perspective, these are controls that you can do. So if I take every single point of where the data is in rest versus data is in motion, every single area, we can actually target that and we put it on a matrix. You will get a picture about where the security loopholes can actually occur. Put that on, and then you can actually get some kind of framework. So cybersecurity becomes extremely important. So of course, with a lot of AI and other things coming into picture, especially with Gen AI, people talk a lot of those. The documents that you do, and you must have, in every industry, we force the industry to actually have some Gen AI strategy. And number two is to have a proper guideline. Because if I start putting documents, knowledge bases, because I can get things very fast, you're actually exposing certain things which are very core to that industry, which is core IP, into something that you probably are not aware of. So being extremely aware of what the Gen AI model does and how you can actually utilize that becomes also a very important piece. And that's where I think probably the industry needs to look at in terms of guidelines and where the future is.
Thank you, everyone. Do we have time for questions? Unfortunately, we don't have time. Okay. Okay, so we are just the start, and already the industry is beginning to be reshaped beyond recognition. The most important thing that we can do is for any manufacturer today is to just start with the adoption of technology so that we are not behind. Thank you, everyone.